So hi and hello there, welcome to the new video of the course, and in this particular video we are going to see how exactly JFET looks in the real world scenario. That means I'm specifically talking about BFW10 and BFW11, and most importantly what are different terminals of JFET and how to identify those terminals in real world scenario. Okay, so for that we need to first understand how exactly JFET looks. So you can clearly see this is how a JFET looks. Okay, this is how a JFET looks. So I will show you in the next video, I will in the real world scenario, how to identify the terminals of JFET. Now this is a kind of theoretical session where we will actually see one shortcut trick to identify terminals of JFET, and at the same time we are also seeing and at the same time we will also see the significance of the body or the substrate terminal. Okay, so don't worry about how exactly it looks in real world scenario and how to identify those terminals. This is what we are going to see theoretically in this particular session, and next video I will just post the video wherein I will show how to identify those terminals practically. Okay, great. So first of all, the very first thing that I can say is that JFET is a 4-terminal device, that is gate, drain, source and substrate. So these are the 4 terminals of JFET. Okay, among all these terminals we are very much well aware of gate, we are also aware of drain, and we are also aware of source, but still we are unaware of substrate. Okay, so substrate, it is also known as body. Substrate, it is also known as body, and at some times it is also known as shield, SHIELD. Okay, so a single terminal has 3 names, that is substrate, body or shield. Okay, it's one and the same basically. Okay, now we will see how to identify this particular terminal. Okay, so for that, the very first point in the shortcut trick is this. If this is me, okay, so I should handle the JFET in such a way that the notch should point towards me. As you can see, this is a notch. Okay, this is a notch and it is pointing towards me, and all the 4 terminals, they should point upwards. So you can clearly see all the 4 terminals, they are pointing upwards. So this is the very first point to remember in the shortcut trick. So there are certain steps in that particular shortcut trick. So this is the very first step. The very first step is that you should hold the notch such that the notch is pointing towards you. Okay, that means if this is your notch, it is pointing towards me, that means I'm standing over here. Okay, so the notch is pointing towards me, and the second important point is all the 4 terminals, they should point upwards. Okay, or they should point at the top side. Okay, so if I look from the top side, this is how it will look to me. Okay, if I'm looking from the top side, you can clearly see this is how it will look. I will be able to see this particular JFET in this way. This all the 4 terminals, they are pointing towards me. Okay, and this notch, it is pointing towards me as well. Okay, this notch is pointing horizontally, whereas the this particular 4 terminals, they are pointing towards me vertically. Okay, I hope you are getting this particular point. Great. Now I'll take this image and I will move to the next point. Okay, next slide, sorry. Yeah, so I hope you are very much well aware with alphabets, that is A, B, C, D, E, F, G and all. Okay, etc up till Z and all. Okay, great. But out of this particular alphabet, we need to go sequence wise, and we just need 4 alphabets, that is B, D, G and S. Okay, so I will just number this particular alphabet. I'll number B as 1, I will number D as 2, G as 3 and S as 4. Okay, that means B means body, D means drain, G means gate and S means substrate. Okay, so let me write over here. This B means body, okay, D means drain, and you have to go sequence wise. Okay, G means gate, and S means substrate. Sorry, S means source. Extremely sorry, S means source. See, don't get confused between source and substrate. You just remember B, that means body. Okay, B for body and S for source. Okay, don't get confused. I had told you over here that substrate, it is also known as body, it is also known as shield. But see, in both of the terms, S is common, right? And we already have one S term that is reserved for source. So why to take those that particular 2 S again? Okay, instead of those S, we will go with B, that means body, and that would be pretty easier to remember as well. Okay, all right. So I hope you understood everything we discussed till now. Okay, all right. So let me just draw certain things over here. Okay, if this is me, again I'm writing, and if this is the notch, and the notch is pointing towards me, right? So this is the notch which is pointing towards me. All right, so as soon as I identified the notch, so what I will do, I will move to the right side of the notch. I will move to the right side of the notch, and I will encounter the very first, oh sorry. Alright, so as I move to the right side of the notch, I encountered the very first alphabet, that is B. And we all know what is B. B means body, right? Again, I'm explaining you. As soon as I identified the notch, then what I'm supposed to do? I'm supposed to move to the right side of the notch. Okay, so RS means I'm moving to the right side of the notch. So this is my notch. As I identified the notch, I moved to the right side of the notch. Okay, as soon as I moved to the right side of the notch, I encountered the very first terminal. Okay, and the name of that terminal is B. Okay, that B means body. Okay, B means body. So this is body. That means what? The terminal present to the right side of the notch, it is known as body. Great. Now what I will do? I will move in the opposite direction of body. I will get the second alphabet or the second terminal, which is known as drain. Great. Okay, I hope you are able to understand up till here. I hope you are able to understand each and everything that we have discussed till here. Again, I am repeating. See, this is me. I'm holding this particular JFET in such a way that this notch is pointing towards me. Okay, so as soon as I identified the notch, I will move to the right side of the notch. I will get the very first terminal, that is body. Then I will move in the opposite direction of body. I will get the second terminal, that is drain. Okay, and then I will again come back to body. Okay, and I will again come back to body. Okay, and again I will move to the right side of the body. I will again move to the right side of the body. Then I will get the third terminal. So this is RS, indicating I am moving to the right side. Okay, as soon as I move to the right side of the body, I will get the third terminal, that is gate. Okay, and as soon as I encountered gate, or as soon as I got the gate terminal, then I will move in the opposite direction of gate. I will get the fourth terminal, that is source. Okay, and this is how we can easily find out the terminals of JFET. Okay, again I am explaining each and everything that we had discussed till now. See, the very first thing or the very first step that we should remember in this particular shortcut trick is that we should hold JFET in such a way that the notch should point towards me. Okay, or the notch should point towards you. This is the very first step. And the second step is that all the four terminals, they should point upwards. Okay, they should point upwards. All right, so this is how it will look from the top side view. Okay, let me move to the next page. All right, so as soon as I identified the notch, I need to move to the right side of the notch. I will get the very first alphabet or the very first terminal, that is body. Great. Then I will move in the opposite direction of a body. I will get the second terminal, that is drain. Okay, then I will again come back to the body. I will move to the right side of the body. I will get the third terminal, that is gate. Great. And then I will move in the opposite direction of gate. I will get the fourth terminal, that is source. So this is how you should, or you can remember the terminals, or you can actually find out or figure out the terminals of JFET. Okay, now I had seen most of the students asking me this particular doubt, that okay, if we are moving in the opposite direction of drain, then why you are not going back from drain to gate, right? Then why you are not saying that we need to move from left hand side? Like if I move from body to drain, that means our drain is present in the opposite direction of body, right? Drain is present in the opposite direction of body. Then it's pretty easier to move to the left side of the drain, and then we will get the third terminal, that is gate. I always tell to that particular students that is also fine, but see, we are following the same steps and the same logic, like moving to the right side and then moving in the opposite direction. Okay, again moving to the right side and moving to the opposite direction. That means, see, first I identified body. I moved to the opposite side of the body. I got the second terminal. Then I will again come back to body. I will move to the right side and I will get the third terminal, and then I will again move in the opposite direction. So basically we are following the steps, we are following the same steps. That is, first I identified the notch, then move to the right side, move in opposite direction, again come back to the first terminal, then again move to the right side, and then again move in the opposite direction. So basically, rather than thinking that way, like first move in right side, sorry, first go to the right side, then on opposite direction, and then move to the left side. So it creates quite confusion at some time. So that's why it's pretty easier to remember only two steps, that is move right side, move in opposite direction, again move right side, again move in opposite direction. This is pretty simpler to understand. Okay, so I will just note down those tips that we had studied. All right, so let me write those tips in the next page, so that this would be pretty easier for you all guys to remember those particular steps. Okay, just a second. All right, so the very first step is that all the terminals all the all the terminals all the terminals of BFW10 or 11, sorry, it's one and the same only. BFW10, not of same, but the characteristics, they are almost similar, of BFW10 and BFW11, that means I'm talking about JFET. Okay, should point at the top side, should point at the top side, point at the top side. Okay, at the top side. The second point is the notch should face towards you. The notch should face towards you, towards you. That means I am talking about this particular point. That means, see, the notch is pointing towards me. Okay, and all the four terminals, they are pointing upwards. Okay, so this is what the first 2 points are. Okay, and you can actually alter the first 2 points. You can write the first point as the notch should face towards you. Okay, yeah, I just forgot to write it towards you. Okay, and the second point can be all the four terminals of JFET should point at the top side. It's one and the same. Like, you can actually alter those points, or you can combinedly form it as a one point. Okay, then the third point is pretty easier. That means move to the right side. Let me take this color only. All right, so the third point is move to the right side, then in opposite direction, then in, I'll write it properly, move to the right side, just a second, move to the right side, then in opposite direction, then in opposite direction, and this particular step you have to follow 2 times. Okay, so I'll write over here into 2, which will indicate that you have to follow these steps 2 times. Okay, again we will see how we identify the terminals of JFET. See, the very first thing that we need to see is that the notch should point towards me, and all the 4 terminals, they are pointing upwards. Great. So from the top side, I will see this particular JFET in this way. Great. Now, as soon as I identified the notch, so I will move to the right side. I will get the very first terminal, that is body, and then I will move in the opposite direction of body. I will get the second terminal, that is drain. Great. Then I will again come back to body. Okay, and then I will move to the right side of the body. Okay, I will get the third terminal, that is gate, and then I will again move in the opposite direction of gate. I will get the fourth terminal, that is source, and that's why I had written move to the right side, then in opposite direction. So you have to follow these steps 2 times. Okay, so this is pretty easy to understand. Okay, no left side, no right side. You have to just follow one step, that is right side, opposite direction, right side, opposite direction. It is as simple as that. Great. Now we are very much well aware of source. We are also aware of drain, and we are also aware of gate region, right? So basically, if we are not at all aware of substrate, right? So that's quite confusing. Like, in the theoretical session, we had seen, and even in working of JFET, we had seen the significance of each and every region. That means gate, drain, and source. Then why the manufacturer has provided the fourth terminal, that is substrate. What might be the reason for that? Most of the website I had seen, they had given some nonsense reason, like just to make the JFET quite symmetrical. If you see in this way, so you can clearly see that I am getting 2 terminals over here. Let me use different color. All right, so see, if you see JFET in this way, or if you make 2 parts of JFET, you can clearly see that I will get two terminals over here and two terminals over here. So just for symmetrical purpose, they had given the fourth terminal, that is body. So this is not the proper reason, or this is not the proper logic, that or this is not the proper significance of the body terminal. I will tell you the reason. See, body is also known as shield and it is also known as substrate, right? So this is the very first point. Let me write over here. Uh, just a second. Yeah. Let me take certain different color. First terminal, that is body. First terminal that is body. Okay, I'm taking first terminal according to this particular shortcut trick. Okay, I'm not referring the data sheet. Okay, first terminal, that is body. First terminal, that is body. It is also known as substrate. Okay, and it is also known as shield. It is also known as shield. Now I had referred different, some of the good websites, and I had also seen most of the YouTube videos. First of all, you won't get, or you will hardly get, any video explaining about this particular body terminal or substrate or shield terminal, right? So let me tell you the significance of this particular terminal. So it is connected to ground. So this is the significance. It is connected to ground. It is connected to ground. It is connected to ground, and is mostly used during VHF or UHF applications. Means what is VHF and UHF? Just a second. Applications, that means very high frequency and ultra high frequency. Let me write over here. This VHF means very high frequency, and this is ultra high frequency, ultra high frequency. Okay, so this is the significance of the body or shield terminal. It is connected to ground and is mostly used in very high frequency or ultra high frequency application. That means if you are going beyond 10 megahertz or maybe 1 megahertz, so that means when the frequency is roughly around 10 raised to 6 hertz, right? That means if I'm talking about 1 megahertz, if we are dealing with the signals, of 1 megahertz, 10 megahertz, 100 megahertz, so at that particular time, this particular body terminal plays a very significant role. Okay, it is generally grounded to counter the noise. Okay, and why it is grounded? The reason is to counter the noise. Okay, why it is grounded? Let me write over here the reason. It is generally grounded, or it is grounded, rather I will write, it is grounded to counter the noise, Okay, we all know, like like when we are designing an amplifier, we are using both DC and AC signal, right? So even the DC signal provides some ripples, right? And if we are amplifying those particular ripples, right, although our intention is not to amplify those particular ripples generated by DC signals, but somehow it gets amplified. Okay, in practical scenario it happens, right? We all know that. So to counter that particular noise, because that particular ripples, that means instead of pure DC signal we are getting a ripple, right? So to counter that particular ripple or to counter that particular noise, okay, we are actually connecting it to, we are actually connecting this particular first terminal, that is body, which is also known as substrate, which is also known as shield. So basically we are connecting this particular terminal to ground. Okay, so this is the reason that why the manufacturer has provided this particular terminal. Okay, and in DC analysis or during DC application, there is no significance of this particular terminal. So let me write over here. During DC analysis or during DC, just a second. During DC analysis or during DC application, there isn't any significance of body terminal, terminal. So at that particular time during DC application, we can actually uh, uh, keep that particular uh, body terminal open, or we can actually ground it. It doesn't matter to us, right? So this is the most important point we should remember. So during DC application or during DC analysis, during DC during DC analysis, we can keep body terminal open, body terminal open. That means it's fine even if we are not connecting it to ground. Okay, or we can also connect it to ground. We can also connect it to ground. Okay, and now you will tell me, sir, but you told that pure DC signal is, we like in DC analysis we won't obtain pure DC signal. We will get this kind of ripple. And over here you are telling that in DC analysis we need to keep body terminal open. It's fine even if we keep it open or even if we ground it, like right. So over here you told us that we won't be able to obtain this particular pure DC signal. Let's suppose it is of 5 volts. Rather we will get a kind of fluctuating, just a second, it won't be like this, yeah. Rather we will get a kind of fluctuating signal, something like this, that may fluctuate between 5 volts to around 4.8 volts. Okay, so this is a kind of ripple like signal we would be able to obtain. Then why you are asking to connect this particular uh, body terminal during AC analysis? This is because during AC analysis we are generally dealing with amplifiers, and during like when we are designing an amplifier, so with the desired signal, this particular DC signal also get amplified. Okay, I mean not this particular DC signal, I mean this particular ripple signal. Okay, this particular ripple signal will also get amplified, and the noise has very high frequency. If you had learned through my earlier videos, you will you would be very much well aware that noise has very high frequency, and if it gets amplified, so that can create a chaos in the entire circuit. So that's the reason that like why we need to connect this particular body terminal to ground, to counter this particular noise. Okay, because this particular noise during AC analysis, this particular noise will get amplified, and it has very high frequency. So to counter this particular signal, we need to connect this particular terminal to ground. Whereas in this particular scenario during DC analysis, we are operating JFET as a switch, right? Either it will be operated in the saturation, or either it would be operated in the cutoff, right? So during DC analysis we will just get this kind of ripple like signal, right? Ripple like signal which will fluctuate between 5 or 4.9 or 4.8 volts, right? Something like that. Okay, but it won't be getting amplified. Okay, it won't be getting amplified. So that's the reason it's like why we are connecting, or like why we can actually connect it to ground, or why we can actually keep it open. Okay, so that's the reason we can actually keep it open, or we can actually connect it to ground. There isn't any such hard and fast rule to to connect this particular terminal in only in ground during DC application. Okay, but it's up to you. If you want, you can connect it to ground during both the analysis, during AC and DC analysis. That would be a good practice. This is what I can suggest, right? Okay, so I hope you understood. I mean, you not only understood how to identify the terminals of JFET, but you also understood the significance of the body terminal. Okay, you also understood the significance of the body or substrate or shield terminal. Okay, if you still have any doubt, if you still face any difficulties, you make sure to ask me in the comment section. Okay, so thank you for listening me patiently. I'm ending this video over here. Thank you.